For question number 2 in this review, we are going to run into a little bit of confusion maybe because it is a neutralization question, and technically that's part of our acid and base unit, but you should have learned about neutralization before. It's basically a glorified double replacement. So when you write out your reactants, you have potassium hydroxide and hydrogen sulfate. When you have a neutralization reaction, as I said, it's a double replacement reaction, so your anions trade places. So your hydroxide group is going to switch over and join the hydrogen. The sulfate is going to go over and join the potassium. What this does is now all of a sudden you have H2O, or water, and some sort of ionic compound, which will be dissolved in the water. So we're going to leave that as aqueous. Please note there is a 2 as the subscript beside potassium because the charge on potassium ion is 1 plus, and the charge on the sulfate ion is 2 minus. So to balance out those charges, make sure there's equal electrons being given and taken. We need that to be there. We are not. This is neutralization because we have OH plus H gives us water. That water molecule is the key to all of this. We do have to balance this before we can do any sort of concentration calculations. So I look at 2 potassiums over here and I need 2 over here. Then I can, the sulfate ion hasn't changed. I haven't changed the number of them, so that can stay the same. And then I can count my oxygens and hydrogens here, and I can see I need 2 water molecules on the product side. So from here you can write out your givens. We've got 0.200 moles per liter is the concentration of KOH. And we know not only the concentration of sulfuric acid, which is 0.115 moles per liter, but we also know that we have, I'll write that down, we have 25 milliliters. Keep my stick figs there so I can see them, of sulfuric acid. Since I have milliliters here and I have liters here, I want them to be the same unit, so I'm going to, instead of writing it as milliliters, write it as 0.02500 liters of sulfuric acid. Now that I have both the concentration and the volume, I can determine the moles. Moles is concentration times volume. In this case, 0.115 moles per liter and 0.02500 liters. I cancel out my units just to make sure that I'm back to doing the correct mathematical operation, and I punch this into my calculator and I get 0.002875 moles of sulfuric acid. But I'm not done here, because in the end I want to know the volume of potassium hydroxide. I can't compare volumes directly, I can't compare concentrations directly because that wouldn't tell me much of anything, but I am allowed to compare moles, so I need to use a molar ratio. So my moles of KOH are unknown, but I do have the coefficient is 2. On the right side, I know not only the moles, which are 0.002875, but I also know the coefficient of sulfuric acid is 1. If I cross multiply, got 1 times the moles of potassium hydroxide, which is just the moles of potassium hydroxide, so that stays the same. And then I have 2 times the number of moles of sulfuric acid, which gives me 0.00575. You'll notice I haven't been rounding this whole time because rounding early in a question will result in different numbers as you keep performing different calculations. Now that I have the number of moles of potassium hydroxide and I have the concentration, I can calculate the volume using a very similar formula to the one I used up here. So I'm going to rearrange it so that volume is what I'm solving for, and that means that it's moles divided by the concentration. 0.00575 moles divided by, and that is 0.200 moles per liter. Moles will disappear. Moles divided by moles is nothing. Liters will go on top in terms of our unit analysis, if you're wanting to do that. We're dividing by 0.2. My final answer is 0.02875. That number looks oddly familiar. Don't forget your units, liters, and I also want to check my sig figs. My fewest number is 3. We have that both present at pOH and our H2SO4 concentrations. So I'm going to round this off, 0.0288 liters of potassium hydroxide.